Hello my dear friends, welcome back to Tomo Tutorials. Today I am going to solve a linear programming problems. One question I've taken here. Solve the following linear programming problems by graphical method. So this is a very important method and very easy method. So after watching this video, you will be very sure that you can do any type of LPP using graphical method. So question is maximize z equals to 6x1 plus 8x2 subject to constraints are 30x1 plus 20x2 lesser than or equal to 300, 5x1 plus 10x2 lesser than or equals to 110, and non-negativity constraints are x1 x2 greater than or equal to 0. Here in this problem, so this maximize z equals to 6x1 plus 8x2, this is called objective function. So we have to maximize. Okay, so it might be profit problem, so we have to maximize the profit. So here subject to constraints means conditions. Okay, so 30x1 plus 20x2, it should not be greater than 300. Okay, so it should be lesser than or equals to 300. Maximum it can be up to 300, otherwise it will be lesser than 300. So this also this must be less than or equals to 110. It cannot be more than 100. It can be 110, but it cannot be more than 110. So here we have to use the graphical method. So friends, you can remember one thing, that we can use graphical method to those LPP having only two variables. These two variables x1 and x2, these variables are called decision variables. If there are more than two variables, decision variables, then we cannot use this graphical method. Then we have to use another method, that is simplex method. So we'll learn that method later on. So here I'm going to solve these equations, this system of inequations. First step is we have to convert these inequalities into equations. Okay, so convert the inequalities into equations. So first step is we have to convert the inequalities into equations. So here inequalities is 30x1 plus 20x2. Now we have to convert this into equations. So equation means equals to 300. Another is 5x1 plus 10x2, here also equals to 110. Okay, and similarly the non-negative constraint also. Okay, now we have to solve these two equations. So I'm going to convert this into double intercept form. So I think you know the double intercept form of a straight line. So these two are two axes, x-axis and y-axis. So double intercept form, okay, let it be cap x and cap y. Okay, so if this is a straight line, so it has a x-intercept also, let it be a, and it has y-intercept also, let it be b. So this is in the double intercept form. So the equation for this line will be, general equation will be x by a plus y by b equals to 1. That means a and b values are x-intercept and b is y-intercept. Okay, so we can easily convert these equations into intercept form. Okay, so step 2 will be convert the equations into intercept form. Okay, so we have to convert these equations into intercept form. So first equation, 30x1 plus 20x2 is equals to 300 is there. So if we let us write 300 only. If we divide whole equation by 300, so we'll get this in the form 30 by 300 is 30 into 10 is 300. So x1 by 10 plus similarly 20 by 300. So it will be x2 by 15 equals to 300 by 300 is 1. So now it is in intercept form, x1 by 10, x2 by 15 equals to 1. So it will be very easy to plot in the graph. So why I have done this intercept form is to make it easier to plot in the graph. Okay, so next step we'll be doing graph. Similarly, another equation, second equation. So 5x1 plus 10x2 equals to 110. So if we divide whole equation by 110, so it will be 5 divided by 110. X1 by how much you will get? 22 plus x2 by 10. How much is 110? 11. So equals to 110 by 110 is 1. So now this is also in the intercept form, x by a plus y by b is equals to 1 form. Okay, so this will be very easy while plotting in the graph. Now one more time let us see the intercept form. So from origin to this point, this is the x-intercept, so value of x coordinate, right? So similarly from origin to this point where the line is intersecting the y-axis, this is y-intercept, that means coordinate of this one, okay, this point. So it will be very easy to plot. That means the value a here is x by a, this value here. Similarly y by b, so this value is the same b value here. So the point here and here we can plot, and thus we can draw the graph. Okay, so after this, so let us see the graph. So I have drawn the graph already, but I haven't plotted the line. So here let us plot for the first line. Okay, so our first line in intercept form is x1 by 10, x2 by 15 is equals to 1. So x1 by 10, so x intercept is 10, so where we have to plot 10, so here x intercept is 10. Similarly y intercept is 15, so we have to plot 15, so it is 15 here. Okay, now it is very easy to join these 2 points. We have to draw a line passing through both these 2 points. Okay, so I am drawing that line. So here I have drawn the line. I've joined the 2 points, and along this line we have to write the inequalities. Okay, not the equation, not the intercept form, but you can write inequalities, so that we can draw the shaded region easily, right? So for the first inequalities I have written here 30x1 plus 20x2 less than or equals to 300. Similarly we have to draw the second equation. Okay, second x-intercept is 22 and x1 intercept is 22, x2 intercept is 11. So here in this graph, so our x-axis you can take we can consider as x1, and y-axis we can consider as x2. So here x-intercept is 22, so here is the point 22, and y-intercept is 11, so we have to plot y-intercept, so 11, so here is the point. So now we have to join these 2 points. We have to draw a line through these 2 points. Yeah, I have drawn the line and written the inequality also. 5x1 plus 10x2 less than or equals to 10. Now we have to set the region. To set the region, we have to decide which side we have to set. Okay, so it is very easy to decide after looking to the inequality. Okay, if we check for the first inequality, this is 30x1 plus 20x2 less than or equal to 300. So it is very easy. So we have to put 0 0. So 0 0 means this is the origin. So where is the origin? Here, this is the origin. This coordinate of the origin is 0 comma 0. So if we plot this point in this equation, inequality, so if this point satisfies this inequality, then surely the region will be this side, because origin is in this side, this region, right? So if we put in place of x1 0 and x2 0, what happens? 30 into 0 0 plus 20 into 0 0. So 0 plus 0 is again 0. So 0 is less than equals to 300. Yeah, so 0 is less than 300. So it is satisfying the point 0 comma 0. So the region will be this side. Okay, so region will be this side. So you have to shade this area, whole area. So this line divides whole plane into two parts. So this part, whole part will be the region for this line. But we have to check for the another line also, for this line also. So let us check for this also. Same way we can use 0 comma 0 here. So 5 into 0 is 0 plus 10 into 0 is 0. So 0 plus 0 is again 0. So 0 is less than 110. So surely this also will be this area. But to get the solution or feasible region, so feasible region will be the common to both the line. Okay, so this area is not covered by this line. Okay, so this is not common, and this area, this region is not covered with this line, because this line solution is only this area. Okay, so the common region is this region is common region. Okay, and another non-negativity constraints are x1 is greater than or equal to 0, x2 is greater than or equals to 0. So x1 is greater than or equal to 0 means x1 greater than 0 means from here to this area it is positive. Greater than or equal to 0 means positive values. Similarly x2 values, so x2 is greater than or equal to 0 means above this line will be greater than or equal to 0. So this region will be the common region. So this region is also called feasible region in LPP. Feasible region means the region where the solution lies. Okay, so we'll be shading this whole region as the feasible region. Here I have shaded the region which is feasible region. Okay, so this is the common region for all the constraints. Okay, so this line also have this region, this line also have this region, this and non-negativity constraint also have this region. So this is the feasible region. The best solution will be lie in this region. And another theorem is there. So the maximum or minimum value will be lying on corner point. Okay, so all this region contains the optimization value, but the corner point contains the maximum value. Okay, here is corner, here is corner, here is corner. Okay, and here is the corner. So this is origin 0 comma 0. Here if we name it A, so it will be x value is 10, y value is 0, 10 comma 0. If we name it B, so it is x value is 4 and y value is 9. And if we name it C, so here x value is 0, y value is 11. So this is the corner points. Okay, now we have to find the solution. Okay, so solution will lie in the corner points only. So we have to check for the corner points only. So here I made the final table for corner points. So we have 4 corner points in the graph. So here one corner point is O, and this A, B and C, and the coordinates also we can easily find out the coordinates from the graph. So here I have drawn the table with the corner points. Okay, so our objective function is maximize z equals to 6x1 plus 8x2. So here for origin 0 0, so if you put x1 x2 value 0 0, you will get 0. So here a is 10 comma 0, so 6 in place of x1 10 plus 8 in place of x2 is here 0. So if you calculate this one, you will get 60. So similarly for this point you will get 96, and similarly for C you will get 88. So out of 0, 60, 96 and 80, so which is the maximum value? So this is the maximum value. Okay, so the maximum value lies in the point B. Okay, so point B is here, so here is the maximum value. Okay, so maximum value lies here. Hope you like it. Thank you very much.